And I'm going to turn it over to Alison Hahn, who we're very lucky to have with us today. She is with the Nuclear Energy Institute, and before she went to NEI, she spent 14 years at the Department of Energy, where she was most recently the Associate Deputy Assistant Secretary for Nuclear Reactors. So we've got the right person leading this panel. Alison?
Thank you. Good morning, everybody, and loving the blinds. So yes, I'm Alison Hahn. I'm with the Nuclear Energy Institute. For those that don't know, that is the trade association representing the nuclear industry across the entire supply chain, from vendors, utilities, suppliers, manufacturers, up to end users, national labs as well. So very happy to be here. I am going to pass it over to the panelists here, but I just want to set the stage for a moment, and I appreciate the comments from Westinghouse and the comments before this panel, because there really is an urgency here. But to start, there are 94 reactors operating in the country, and they have been operating reliably for decades now, providing almost 100 gigawatts of clean, reliable electricity. The majority of those plants are already permitted and licensed to operate out to 80 years or have committed to operating out to 80 years, and so these assets are absolutely vital for our electricity grid. But there's also been a couple comments that there is an increased energy demand, and a lot of it comes from hyperscalers, and we need more electricity to meet that demand. So what we're looking at now is advanced reactors, and that comes in a variety of different coolants, whether that's high temperature gas, molten salt, liquid metal, water as well, and across all sizes, from the gigawatt scale reactors that we have operating today down to 1 megawatt micro reactors. And so there's really a product out there that meets your need depending on what it is that your requirements are. So just want to set that stage. And then also, the advanced reactors are here. You know, this is not something that's going to be built in 10 or 15 years. The two AP1000s down in Vogel, down in Georgia, were already mentioned, but we're also seeing a lot of construction and movement on those advanced reactors. You've got the TerraPower Natrium moving dirt in Wyoming. You've got X-Energy's plant out at the chemical plant in Texas. And you've also got a number of new programs that were just recently initiated to get these deployments even faster. You've got the Department of Energy's Reactor Pilot Program. That includes 11 projects hoping to deploy advanced reactors with a goal of 3 of those projects by July 4th, 2026. So within the year, we're going to start seeing some of these reactors come online. This is not something that's, we'll get to it when we get to it in 10, 15 years, but really soon. And in order to be able to deploy these and to commercialize them, not just one demonstration, but to commercialize the technology, we need to see an order book. We need to see those commitments made by those end users. But to get there, we also need a supply chain to help us build these. So I'm very happy to be here today with our panelists here. I'm going to stop rambling and hand it over to our panelists to take about 5 minutes to introduce themselves and their organizations as well. So first, I want to start with Tim.
Thank you. Thank you for having me here this morning. Really appreciate it. My name is Tim Mediate. I am the Director of Project Procurement at Westinghouse. I've been at Westinghouse for 19 years, and I actually am a native to the Pittsburgh area. Grew up just east from here in Irwin. Went to Hempfield High School and stuff, so very proud to not only have lived here pretty much my whole life, but to also be at a good company that's helping drive nuclear to the forefront and be a leader in the technology. Jacques was up here. He gave a lot of great stats about Westinghouse. Stole some of my thunder, but that's okay. Westinghouse, as he said, is a global leader. We've been innovating for over 135 years. We do have a reactor that is deployable, ready to go. 6 of them are actually, as he said, in operation. Not a lot of people and a lot of companies can say that they have new passive technology that's actually operating and operating at record numbers. The capacity factors and the availability of the AP1000 is over 90%. A lot of the reactors that are currently out there that are non-AP1000s, you're maybe between 70 and 80%. So these reactors are online longer, providing power and more frequency, and it's more stable than what we've had in the past. So we're very proud of that. Another thing is with the fuel outages. Right now, your first fuel outage is probably 28 days, and then the second one's 19 days. You look at current non-AP 1000s out there, you might be over 30 days. So again, the more these plants are online, the more power that they're providing, and the more reliability we have to the grid. Upon that, there are 14 under construction right now in China, so it's showing that nth of the kind. Whenever you have a design and a set design and continue to deploy that design, you're able to do it. So the Chinese are doing it, and we know that we can do it as well. So as Jacques pointed out, we did put together a 10-unit plan that we are sending to the White House to help us deploy that and execute on that plan. Besides that, we do have 6 that are currently under contract in Europe. We have 3 in Poland, 2 in Bulgaria, and 1 in the Ukraine. And we're actively working those projects right now. So when we talk about the supply chain and having the supply chain ready to deploy not only what's in Europe, but here in the United States, we're actively doing that right now and trying to set our supply chain up for success. So that way we have the people ready to go and ready to deliver the equipment safely with good quality. So I look forward to the panel discussion here, and I look forward to talking to some of you during the break. Thank you.
Thank you. Pass it over to Sandeep.
Great, thank you. Good morning, everyone. It's such a privilege to be here. My name is Sandeep Dudhwewala. I'm the Senior Vice President of Corporate Strategy and M&A at Vistra. My connection to Pennsylvania is I spent 2 years in Pennsylvania going to business school here, so I'm really fond of my time in Pennsylvania. So Vistra, for folks who don't know, is the largest competitive generator in the country. We have about 41,000 megawatts of power generation across nuclear, natural gas, some coal, solar, and battery storage. And we also have a retail business with about 5 million customers across 16 states. One of the things that Vistra is really proud of is that we prioritize our customers. We give them what they are looking for. And consistently, our customers have told us that they are looking for reliable, affordable, and environmentally friendly energy solutions. So we prioritize that in that order. And that's where nuclear plays a big role. You know, it's a reliable source of power, and it's emissions free. So it plays a big role in Vistra's strategy. And with the acquisition of Energy Harbor that we completed last year, we acquired 3 more nuclear plants. So overall, Vistra owns 4 nuclear plants, 6 reactors, and with about 6,400 megawatts of capacity. One of them is, one of the plants is Beaver Valley. It came up this morning. It's located right at the site of the Shippingport Atomic Power Station, which was the first civilian power generation plant in the world. So we are really proud of that legacy. So nuclear plays a big role in our strategy. We also believe it's not just a legacy asset. It's going to play a really important role in the decarbonization and the resiliency of the grid looking forward. And as load is growing, we are living through times of massive load growth, driven by electrification of the economy, driven by demand for data centers, for AI and cloud. And we believe nuclear is going to play a really important role in making that happen. So we are looking forward to that. We are looking forward to making that happen. And we are excited about nuclear and our experience and the strength that we bring with our capabilities in nuclear. Thank you.
Thank you. Robert.
Is this thing on? All right, we're good. I'm from Kerotest Manufacturing Corporation. We've been in Pittsburgh since 1909, and we've been located within the city limits that entire time. We moved over to Hazelwood 30 years ago, a little before the Hazelwood Green boom has occurred here, and we've been very happy there. So we welcome the Hazelwood Green folks. We've been an employee-owned company since 1983. So Kerotest is owned by its own employees. and that's been going for 42 years. Our primary nuclear activity took place in the 1970s, really starting with Westinghouse. I was an employee out there, Tim, and Kerotest lured me away. So I joined Kerotest in 1972 as a nuclear marketing consultant. Even though I was an engineer and didn't know anything about marketing, they took a chance. From 1972 until the early 1990s, Kerotest supplied thousands of valves to nuclear power plants all over the world. I don't know if Jacques is still here, but I spent some time in Paris in the 70s when he talked about that, calling on Framatome. Maybe he's a Framatome guy. I'll have to check with him. But we got valves everywhere. They were made right here in Pittsburgh, actually made on Liberty Avenue. It was a good 20-year run. That ended. 3 Mile Island didn't help. And at this point, Kerotest has had to focus on a different primary market. It's the gas distribution market, people's gas, people like that. We sell those kind of valves, different kind of valves to all the gas utilities throughout the United States. We've got valves running up and down your street in those gas lines. Plastic valves, steel valves, and other products. Regarding the nuclear activity of Kerotest, and by the way, I was a Navy nuclear guy. I worked on the buying valves for the subs and the aircraft carriers back in the 60s, and eventually ended up at the commercial division of Westinghouse. And we basically sold that business in the 90s to a company called BWIP, which was a Borg-Warner industrial pump division, and they bought a whole bunch of guys. They bought our products for nuclear to support the ongoing power plants that were already functioning. We did not give away our technology. We still have all of that technology today. There was a non-compete for 5 years, and that ended a long time ago. Besides supplying valves to the nuclear power plants, we were also participating in 2 projects to enrich fuel for those nuclear power plants. The first one was the gas centrifuge enrichment project. That was a DOE-driven project under the primary contractor at the time. They had a prime of Union Carbide in Oak Ridge National Labs. We received the contract in 1979. We beat out 50 companies for that business. We designed a product that we had never made before, using materials and design concepts we had never used before. Built the first articles in 9 months, qualified them, got a contract for $25 million. I have to tell you this, I walked into the chairman of the board at the time, and I said to him after we got the contract, I got good news, I got bad news. He said, what's the good news? I said, I got this contract for $25 million. We were kind of working it as a side issue, you know, one of those skunk works things. He said, well, that's the good news. Yeah, what's the bad news? I said, well, I need 50,000 square feet, millions of dollars worth of equipment, a couple of hundred people, and I got to ship product in 18 months. That's the kind of stuff Kerotest has done. And he told me, you know, quit talking, get busy, and we pulled that off. We leased 50,000 square feet on Smallman Street, 2 blocks from our existing plant at the time, made all the products, shipped them all, and then they canceled the project. Again, 3 Mile Island had a major impact on the decreased demand for fuel of the projected plants at the time, and DOE decided not to build that facility. We did the same thing again in 2007. Spin-offs from that original activity became the ACP project, American Centrifuge Project. That was being run, designed by Fluor Corp out of South Carolina. They were hired by USEC, United States Enrichment Corp., and they were going to build this plant, this time in Piketon, Ohio. That time we got a contract for $90 million. made a whole bunch of stuff, canceled. The tsunami in Japan literally shut down a big portion of the worldwide demand for fuel. That time we rented 50,000 square feet in Oakmont, built an entire functioning clean room internal to that facility, hired a bunch of people, bought a bunch of equipment, made a whole bunch of stuff, and then they canceled it. You know, 50 years of nuclear in 5 minutes is hard. I'm almost done here. 2010, I attended the Westinghouse Supplier Conference entitled "The Nuclear Renaissance Has Arrived." Tim, I don't know if you were at that one or not. But I got out the old drawings, made some forgings, not from Brian over here, but maybe that'll change. Made some forgings, machined some parts. We were ready to get that end stamp again. And then it just all went away. So what have we been doing lately? For the last 5 years, we are supplying our valves to the Westinghouse Columbia Fuel Fabrication Facility in South Carolina. And meantime, we're waiting in the wings over there in Hazelwood for exactly what's being discussed at this conference. Somebody needs to buy a whole bunch of valves, and we're here to make them right here in Pittsburgh. And we know how to do it. End of story.
Thank you. And now we're going to go over to Brian.
Okay, good morning, and I would also like to echo it's an honor and privilege to be here this morning speaking with everybody. My name is Brian Hoover. I'm the president of North American Forge Masters. North American Forge Masters is a joint venture, 50-50 venture between the Elwood Group and Scott Forge. We are located in Newcastle, Pennsylvania, about 60 minutes north of Pittsburgh, and we sit on the Elwood Quality Steel campus. This facility is the only facility in North America that is capable of producing ultra-large commercial nuclear-grade forgings up to 330,000 pounds finished. And we take it from melting the steel, forging, rough machine, and final machine the product before leaving our hands to our customers. JV partners have privately invested over $500 million in our facilities over the last 10 years. Without this investment, based on recent events, if you're not aware, the Department of Navy would be in serious trouble because our main competitor, Lehigh Heavy Forge, who's in Bethlehem, and they're great, it's a great team and we work closely with them, their steel producers shut down recently. So Steelton closed just suddenly. So now we're the only place in America that can produce these large forgings of steels. And we are working very closely with Lehigh Forging, selling them steel now also so that they remain viable also, because we believe there should always be two sources in the United States so that there's not a one failure point. So we are the heavy open die forge facility of Elwood and Scott Forge. Together, the two companies have been in business over 250 years of combined experience. We start at 57 tons and we go all the way up to 222 tons. Like I said earlier, which at the end makes around a 330,000 pound forging. This can be the heads, tube sheets, shells, support skirts, etc. for reactors. We've taken many steps to prep ourselves and the nuclear manufacturers for the potential. Many developers have novel designs, and I mean novel, in both material and weight size. In this regard, for a specific customer, we recently, with the support of Pennsylvania grant monies, melted the heaviest domestic stainless steel ingot by a historical factor of 2x in Newcastle. Ingot was successfully forged, heat-treated, mechanically tested, rough machine, and non-destructively evaluated. These activities confirm that NAF has the ability to successfully produce ultra-large forgings of stainless steel to the size, weight for the application. Currently, our primary customer is the DoD and Navy. We forge and machine all the propulsion shafts for all surface combatants and submersibles Navy platforms. We also provide critical forgings for the nuclear engine room for both submarines and aircraft carriers. Based upon this Navy nuclear work, we feel we are properly positioned to kickstart the American commercial nuclear revival and support clean energy and good-paying U.S. manufacturing jobs and careers. We also provide large commercial forgings for the industrial construction and infrastructure in North America, large hubs, shafts for drawbridges. The new J.P. Morgan building in New York has what they call banker blocks, where everything is tied together to those blocks, and hydro projects for electrical producers. We employ roughly over 35 highly skilled and trained employees in our facility. When the nuclear industry is ready to take off with co-investment from developers and the U.S. government, the DOE, we can and will multiply capacity very fast to meet the demand. We have a great pipeline of talent available to us, and we have fostered a great relationship with the Newcastle Technical School. All the components on the nuclear facilities, for all nuclear facilities, can be made domestically in the U.S. Reactor pressure vessels, containment, steam generator, pressurizer. Currently, there's a lot of misinformation out there that these products cannot be made in the U.S., and they can be made in the U.S. We are available and ready to serve. All products are designed for manufacturability to eliminate as many welded components as possible, which in essence saves thousands upon thousands of man-hours of welding. The elimination of the weld significantly reduces the in-service inspections of those welds for the life of the reactor. We are not just a heavy forge facility, we are near-net products to reduce downstream added value and reduce lead times. So as we look forward, the only thing I would close with is that I feel it's very important that as we're all here and we're all supporting the industry, that we work to provide, promote, and protect the American manufacturing industrial base. Thank you.
Thank you. And I'm from Eastern Pennsylvania. Don't kick me out. But Bethlehem Steelworks, it's a little surreal to see. It's like a casino and event space now. So it's a little different. Okay. So I have a few questions that I would like to ask the panel, but then I also want to open it up to audience questions. So I'm going to start with a couple of these questions up here, and then I'm going to kick it out to you all, so start thinking of some questions, and we will turn to you in just a little bit. But to start, there are multiple advanced reactor technologies in development, many requiring new components, materials, manufacturing approaches beyond what today's large light water reactor supply chain provides. And there's a real need to adapt quickly. From your perspective, what are the most significant challenges to support these first-of-a-kind deployments? And I want to start with Robert on this one.
Well, that's a difficult challenge to deal with 11 different potential reactor designs. Some are using sodium for coolant. Some are still using basically a light water reactor approach. The problem is we're not called Kerotest Research and Development Corporation. We're called Kerotest Manufacturing. So the biggest question for us is, do we want to divert our resources, our technical resources and other resources, away from the commercial enterprise to work on completely new reactor concepts that may or may not ever come to fruition? We're an employee-owned company. We need to make a profit. It's really difficult to spend an enormous amount of your capital on something that's quite frankly fairly high risk. You know, you just heard me talk a few minutes ago about cancellation. You know, when I look at this, I think I really like what Tim's doing. You know, he's going to build about 10 reactors. I'd like to work on that.
We're hiring.
Tim's my new best friend, by the way. He doesn't know it yet, but oh, he will. If you placed an order with me and you gave me a spec for these new reactors, I would be interested in developing a plan to produce a product that would serve whatever that application might be. We did that with the gas centrifuge enrichment activity that I mentioned to you. Brand new product, never built before, designed it, built first article in 9 months, went into production in 18 months. Now, I happen to read the information on the DOE site, and I see that we're going to have 3 reactors going critical on July 4th. So I would think Kerotest is like that ship sailed. I mean, if you don't have equipment already identified that works in those reactors, if you think you're going to get them in 2 months or 3 months to put them in that plant and fire that thing up on July 4th, I don't think I'm your guy. I'd like to be, but I would find that hard to believe. Our goal is to support whatever commercial reactor business there is. Tim, Vistra, they're going concerns. We need to focus on that. But I wouldn't turn down an opportunity to work on a new reactor application. We do that. We know how to do that. But I think the long-term commercial success of that is something that's fairly high risk for a company that's primarily a manufacturing company. But we've done it before. We'd be happy to try it again. We have all the means to do it. We have all the analysis, software stuff. I mean, this is business. It's a new product. We do that all the time. So we'd be happy to take a shot at it. But I would say with the July 4th deadline for 3 plants to be critical, someone's got to already have a bunch of stuff designed that already works, or I don't think you're going to make that date. It's the best I can do.
Those one-off plants and that uncertainty is significant. Brian, do you have anything to add there for the first of a kind?
Yeah, I think the key thing here is when do we get the signal to start ramping up? Because, as Bob said, a lot of specialized equipment, tooling, big machining centers you have to buy to get going for this. And the biggest risk is, without that, who's going to go invest the money? Who's going to go start it? It's good to hear that Westinghouse, the first 10 are going to be the same, because that makes it a lot easier that way. There are a lot of novel differences between the different folks that are claiming they're going to build nuclear reactors or small modular reactors, but keeping them consistent would be really nice. If you're not aware, with the Navy, when you read about how we're behind on building submarines and we're behind on building carriers, the problem is like Jock said before, they don't keep them the same. They call it the same model. It's a Virginia class, it's a Los Angeles class, but we're making product right now for what they call Block 6. And there could be 10 of those submarines in that block, and each one is different, which stops and delays everybody, right? So you've got to get some consistency. We've got to get a consistent signal that says this is the work that's coming to you. It's guaranteed, because if it doesn't show up, it's all a nice talk, right? We're just talking about it, but it has to kick off somewhere. And hopefully with the Westinghouse getting the 10 that are exactly the same, that will help the supply base really gear up and get after it.
Thank you. So as the industry moves beyond those first builds and begins to develop that true order book for advanced reactors, you mentioned supply chains. They need to evolve from that bespoke project by project solutions to that repeatable, scalable production. And we are starting to see these order books. Westinghouse has mentioned it. We're seeing it with X-Energy and a couple of other vendors. They are building that order book out and providing that commitment there. So how do you see the supply chain shifting to support that transition from that first-of-a-kind, one-off reactor build to that nth-of-a-kind, filling out that order book deployment? And what conditions are most important for sustaining that growth for you? And so for this one, I want to switch it around. And Brian, do you want to kick us off here?
Yeah, sure. Just like I was saying, it's really about the steady demand signal and knowing that we've got product coming to us years in the future, so that we make the right investments, we hire the right people, we have no interruptions to the flow of orders. Not to harp on the Navy, but if you follow them, 87% of the nuclear carrier market right now, the supply chain, 87% are sitting idle because they've got 3 carriers under construction in Newport News, and they're not moving fast enough. So now this causes a problem for those companies, right? Causes a problem for the supply chain. They have to now go find something else to do to offset that work they thought they were going to have for many, many years in a row. So this causes the problems in the supply chain because you start, stop. So once you do that once or twice, you decide, I'm moving into a different marketplace, and they're going to have to show me something really great for me to get interested in that market again. So again, steady signal, no disruptions, keep the flow coming.
Robert, anything from you?
Well, to ramp up to support a much higher volume of activity, we're going to need to add facilities. I mean, obviously, like Brian said, we're not sitting there with a bunch of machines sitting idle, with people sitting there waiting for someone to give us an order. So it takes time to ramp that up. It just so happens that I've got a vacant lot behind my building in Hazelwood, so I don't actually have to lease 50,000 square feet from somebody. I'd be happy to build that building, put that equipment in there, hire a bunch of people in Hazelwood and make some stuff. And it also so happens that Hazelwood Green is the home of ARM. ARM is Advanced Robotics for Manufacturing. Kerotest is a member. I wouldn't buy an army of robots on day one, but we do use robotic functions for welding right now. We're looking at expanding the robotic activity. So if I need any robotic equipment in order to be ramp up production and be cost efficient, I think I can literally walk down Hazelwood Green from my plant and get all the help I need. So I really just, I'm still a marketing consultant like I was in 1972, and I just need an order, and we're good to go.
Easy. Let's do it. Okay, so let's go down the panel here. So we've talked about the challenges vendors face for the first of a kind and nth of a kind, but that relationship runs both ways. I'd like to turn now to the advanced reactor developer themselves. And you mentioned it previously, but can you expand on how you're working with the supply chain partners today to make sure that the right domestic capabilities are in place when your technologies are ready to move out to your 10 reactor order book?
Yeah, so with the AP1000, whenever we were doing China, I would call that was first of a kind. The design wasn't complete, and we were learning as we went. We had to deploy, we had to go quickly, but again, as you're building and also still finishing the design, that's where a lot of things, start coming up and some of those issues occur. We learned a lot from the China builds. We took those lessons learned, we put them on to the Vogtle and VC Summer builds. And as Vogtle continued to go, everything we learned on Vogtle 3, we then applied to Vogtle 4. And as Jacques pointed out, we actually improved and were 20 to 30% less spend on Vogtle 4 than we were on Vogtle 3. So as we continue to finalize the design and have that design go, now it's locked in. So with these 10 reactors, that's the design. There is no more first of a kind. We built it, they're operating, they're ready to go. The pieces that are in there, the parts that are in there, the equipment that's in there, that's the types of things that we're working with our suppliers to ensure that they're not changing what they're doing. There's obviously going to be obsolescence and things that roll around, but we're trying to communicate with our supply base that we are not making the changes like we did before, where we start going down a road and then we make a change and then a change again. That has now been complete with the nuclear island design. How we are engaging our supply base is upfront and early, right? We've been heavily talking to them since 2021. A lot are waiting for orders, and we understand that. But the one thing that we are very keen on is we don't want to do false starts, right? We want to make sure that we have a good plan together. We work with the suppliers as partners. Westinghouse, specifically my group, we do not do transactional purchase orders. We build partnerships with our suppliers to ensure that they understand what the design is. I don't want to send you design specs, technical requirements, and have you guess. We will go through the design specs. We will ensure everybody's on the same page and then make sure that they're ready to go. The other thing is capacity. I don't want to overload shops. We've overloaded some shops in the past, and we felt some pain with that. So that's another thing that we got to learn, and we want to make sure that there's not just a sole source. We're trying to expand the base and develop new suppliers, so that way with the 10-pack that we're working on, there are different levers we can pull when necessary to make sure that we have a broad range of suppliers that can be a part of these projects. So by engaging early, understanding capabilities, understanding capacities, understanding any gaps that need to occur to get them to the level that we need them to be to then execute development plans is what we're doing right now. specifically with Poland, Bulgaria, and the Ukraine projects in Europe, and we're pushing that into the US as we speak.
Fantastic, thank you. Okay, from the utility perspective, making a commitment to advanced reactor projects requires confidence, not only in the technology, but the industry as a whole. What do you need to see in terms of the readiness, reliability, or the cost certainty before you might feel comfortable moving forward with placing an order?
Yeah, so our customers are looking for safe, reliable, and affordable power. So with any of these first-of-a-kind technologies, there's inherent risk. There's a risk of technology, there's a risk of cost overruns, there's a risk of schedule overruns. What we need is, we need mechanisms to manage that risk so we can provide that safe, reliable, affordable power to customers. And so from our perspective, we need to figure out ways to manage that risk that makes these investments investable. We think the competitive markets are best suited for that, where you can allocate risks and returns that are commensurate with that. So I think Vistra, the way we play in this space is to bring that risk sharing model that we can work with our customers, with our stakeholders, to give them that reliable, safe, affordable power. So in my mind, the biggest challenge we have is how we get all stakeholders engaged in making that happen, and go from the first of a kind, which will be riskier, and then go through the learning and make it less risky down the road.
Excellent, thank you. So I want to pause and open it up to the audience if there are any questions. Hands high so I have one right there in the plaid shirt. I don't have a laser pointer or a microphone. There we go.
Hello, my name is Tomas. I am a master's student at Carnegie Mellon, studying energy science. And I know that you guys seem to all be ready to sort of put our models into production. But I was curious, since Russia is our main supplier for uranium and enriched uranium, if you guys have any plan to bring that production to the US, considering that the administration has decided to stop buying enriched uranium from Russia in 2028 within that time. So how do you guys plan on fueling these reactors and making it sustainable for the US to essentially continue building nuclear reactors?
So I'll start with Westinghouse, and maybe they can explain how they're going to use the LEU fuel for their AP1000, and then maybe I'll expand on the HALO fuel part.
So yeah, I mean, Russia does have large uranium supplies, but that is not Westinghouse's only place to get uranium. Our owners are a big uranium company out in Canada, as well as there's other places around the world where you can get it. We are constantly delivering fuel through our Columbia site to all of the reactors within the United States and around the world, as well as our site in Sweden. We are actively creating not only fuel for the PWRs and Westinghouse designs, but we also developed the fuel for the VVR design, which is a Russian design, and we're providing fuel to the Russian reactors as we speak. So I really don't see an issue with what's going on in Russia and not being able to fuel these power plants.
And I'll, just because there's no non-LWR or HALEU reactor vendor up here, for HALEU, the high assay, low enriched uranium, which is slightly enriched above what the fuel is used for the AP1000s, the Department of Energy is investing a significant amount of money. It's $2.72, don't forget the second two, billion for enrichment and conversion, bringing it home domestically. There are a number of awardees that were selected last year. Department of Energy is moving through those task orders to develop that capability. There's also, through these new executive orders, a fuel pilot program that the Department of Energy is utilizing its DOE authorization capabilities to, again, bring that technology to market faster. And so, yes, it is a gap, but yes, it is also being addressed by the Department of Energy and by commercial entities currently. So I just wanted to put that out there as well. Are there any other, I thought I saw another hand around that area.
Over here.
Oh, sorry. Go ahead.
Thank you so much for the conversation today. My name is Arvind Venkat. I'm a state representative here in the North Hills. My question is about the NIMBYism that seems to be associated with nuclear power and building new nuclear plants. And as a public official, it's something that I hear from my constituents when there is a potential proposal. And so I was curious how in your work you deal with the not in my backyard phenomenon that seems to come up with nuclear power, especially with the plan to use nuclear power with artificial intelligence data, which have their own set of not in my backyard concerns as well.
Sure, I can take that. So I think that's right. I mean, there is always a challenge when we try to build something new. I think we have to point to 94 reactors that you mentioned earlier that are running safely for a long time. I think in the US, the safety standards are really high, and the nuclear industry has performed and has delivered on safely running and operating these plants. With any new development, I think we'll always have concerns and issues that we need to address. So we do that, whether it's nuclear or solar or wind or whatever form of generation. I think we have to point to the benefits that the investments provide to the community, the economic development, the growth that comes along with it. So it's really about kind of painting the full story, the big picture that you have to see that you get with those investments. And so I think that's a challenge that the industry faces overall, but we need to work together to make sure that we can address those issues holistically.
Yeah, I'd also add, in the past couple of years, support for advanced nuclear has dramatically increased. The nuclear industry wasn't always great about communicating, but the past few years, they've really taken a step forward to get out there and have those conversations. There's a program in the audience, I believe you'll hear from later, Gateway for Accelerated Innovation in Nuclear. Rambled that off quickly, sorry, GAIN. I've been at some of their events the past few years, meeting at libraries and fire halls and just having a conversation with the community and just being available to answer questions, and having those types of conversations just makes it more approachable. You can ask the questions that you're concerned about and you can get a straightforward answer, and that's, I think, has done tremendous job to increase that support nationwide as well. Is there another, oh, go over there. Oh, sorry, getting out of line here.
Hello. Hi, friends. Long time no see. Victor Ibarra Jr. with the Clean Air Task Force. A question I have for the folks on the panel, it's an overly simple question, but obviously there's layers of complexity. The NRC has been in a process of modernizing its opportunities to license, operate new nuclear reactors in the United States. At the same time, as the administration has come in, they are very interested in deployment of new advanced reactor technologies, to the point that they've established a reactor program and a fuel program to help spur the deployment of new reactors. At the same time, there's confusing sentiments from Congress with the passage of One Big Beautiful Bill Act, H.R. 1, where they sent investors a bit of a confusing signal with some of the FIOC provisions related to how that might affect the deployment of new reactor technologies. All that being said, thank you all for the comments that you made today regarding how you might be interested in moving forward with new reactor deployment, maybe the AP1000s, for example. But to that extent, just for the folks in the room, what would be the most helpful policy-related recommendations that you would make that would give you that certainty to build a standardized order book of new reactors in the US that could help get us from this piecemeal position that we're in, where we're focusing on R&D, which is beautiful and great, we need it. We're focusing on first-of-a-kind deployments. Again, we need that as well. But how do we get from 3, 4, 5 grid-scale-ish reactors of a first-of-a-kind to a 20-plus order book of maybe 1, 2, or 3 major players that then can help us address the challenges that we're facing with either grid resiliency, climate goals, et cetera? Like I said, overly complicated question, but.
Thank you. Who wants to take that first?
So I would say that the one thing is commitments, right? We say all the time that, you know, we want to do this and everything, but the one thing that we need is a commitment from the government as well as commitment from our customers to be able to start deploying these reactors. We at Westinghouse, we're also trying to look at different other ways to, get engaged sooner, engage our customers sooner. But it's all about building that plan and trying to execute to that plan. I don't think I have a one answer that's going to answer all the questions that you asked there. You said a lot, but it is really comes down to commitments and having that commitment from the government, from our customers, so that way Westinghouse can give that commitment to our customer or to our suppliers, and again, not have these false starts like we might have had in the past.
I can add to that. So I think we will need a multi-pronged approach for policy. I think the first thing I would say is investing in the supply chain, investing in the workforce development to make sure that the industry is ready for that growth. So I think that's number one. Number two, as we think about the first of a kind deployments, we need to make some targeted investments to make that happen, to jumpstart those first of a kind reactors. And then number three is to create the right market signals, which are sustainable, that are enduring, that can enable that long-term growth, where you go from the first of a kind to the nth of a kind over time. So those three things come to mind as the key kind of policy objectives.
Perfect, thank you. And there was another one right by the window. Yep.
Hello, my name is Albert Whale. I'm with IT Security Solutions. We're partnering with Ally Power rather, and the National Center for Urban Studies for workforce development as well as cybersecurity. What plans are you putting together to improve the power grid's resistance to threats on the outside that are unseen, to maintain that integrity of power being presented to both our AI platforms here in Pennsylvania as well as the data centers that are going to be built in Duquesne and other points around the country?
So I just want to make sure I get the question right. So I think the question is about cyber security and what we are doing about ensuring the power is safe. And yeah, so Vistra is a competitive power generator. What we want to do is make sure all our power plants are running safely and they are secure. So we deploy the best of the class technologies, obviously using AI as well, to make sure that our power plants are secure and they are safe from any cyber threats. Power plants, they are a critical part of the economy. They play such a big role in running every aspect of the economy. So as Vistra, we make sure that we prioritize that. We prioritize how we can safely run and operate our power plants. We don't play a role on the grid, so we are not a T&D, a wires company. So there are utilities like Duquesne and others who invest. I've been on that side as well in my career, and I know that they also take it very seriously. They also invest in resources to make sure that they stay ahead. And it's a constant kind of cat and mouse game in many ways, and so you have to always stay ahead and keep making the investments to ward off those threats. So I think we need to continue to challenge ourselves and make sure we are deploying the right technologies at the right time.
Agree with everything, and Westinghouse is a technology provider. Whenever we're starting these new projects, and just for instance, what we're doing in Poland and Bulgaria, we have our cybersecurity teams talking to the customer's cybersecurity teams. So that way we're working together to understand what potential threats are out there, and we're starting to develop those design parameters right now because, depending on what grid they're on and what country you're in, different threats, things are set up different ways. So by planning and starting now and getting engaged with them now is going to help us make sure that when these plants are up and running, the limits of attacks will be minimal.
Okay, thank you. I'm going to go one question myself first, because I'm going to cut in line here, and then we'll go back to the audience. So think one more. So by expanding the domestic supply chain will mean attracting vendors who haven't traditionally worked in nuclear. Today, the industry standard of NQA1 can be steep for new entrants because of its nuclear-specific documentation and those specific oversight requirements. By comparison, there are other codes and standards that are already widely used across many other industries and provides a strong foundation for quality management. An example is ISO 9001. From your perspective, what's the best way to lower these entry barriers while still ensuring vendors can meet nuclear's strict safety and quality expectations? I'm going to start with
I'll go. Yep. I would say it's going to come down to everybody needs to look into what's required, how much does it cost, and then is it funding from the prime? Is it funding from the government? Is it a joint funding based upon you recognize you have so many orders coming, or there's going to be this flow of work coming to you? So it is expensive. I don't think anybody's just going to run out and do it without some sort of commitment. But I think there's going to have to be a joint partnership there between the contractors and the suppliers to make this happen.
Thank you.
Let me make a comment. Well, I was on the ASME Nuclear Working Group on valves. We wrote the rules for nuclear valves. Also, on committees for the qualification of things like main steam isolation valves. And we've had an end stamp. We had an end stamp for 20 years. We're ISO qualified. We've got ISO audits coming out our ears. I wouldn't be interested in lowering the standards. I think we keep them. I don't think trying to figure out how to do this with less quality activity is a really good way to go. But one of the big differences in today's technology is that if you go back to the 70s to the 90s, we had a lot of people in quality assurance writing down serial numbers and trying to have traceability on every part. You got software these days. We've got it. It's got traceability built into it. So you can do this task significantly less expensively and, frankly, with a lot less human error with today's technology if you just have the right software programs. So, if you think of the questions we've had about, well, there's issues about licensing nuclear plants. I think the last thing you want to do is to say, well, we need them licensed, but we're going to reduce the quality while we're at it. That's not really a good idea in my view. So I would just suck it up and do what we got to do and use the technology that we have to get it done.
Just want to clarify, we are trying to license the plants more efficiently. We are not in any way lowering the standards. There is a very good reason that the Nuclear Regulatory Commission is the gold standard across the world. They will continue to be that gold standard. We're just trying to make it more efficient. So just clarifying that little point there. Anybody else on that one?
No, I'll echo, again, yeah, we want to make sure that we're building safe quality plants, right? And we don't want to lower quality in any ways, but we can do things better. And that is one thing that we're actively doing right now. Suppliers that have an ISO 9001 program, you're not that far away to be able to do safety-related items, specifically NQA1. There's not a certificate out there that you hang on your wall saying, I got NQA1, right? It's an 18-step chapter process, and you just make sure you build your program around those and you follow the program. Once that program is built, I think that's where a lot of the issues come into play, is people deviate from the procedures, deviate from the quality manuals, and that's whenever problems start occurring, and that's when costs start going up because you're redoing work instead of doing it right the first time. So as, again, Westinghouse, as we're partnering with these suppliers, we're trying to ingrain that culture into not only them, but into their managers, and their managers need to ingrain it down into the workforce, that this might take you an extra 5 minutes, but that extra 5 minutes is worth it to get a good product out the door. Because if you deliver this product and you do shortcuts and you get questioned, that question's not just going to be on that product. It's going to be everything you've done for the past 20 to 50 years because of a shortcoming you might have had. But if you build that culture into your workforce, to me, it'll help us work efficiently. And like you said, getting away from paper and getting more digital, I think will also help us keep that traceability and make things go a lot faster than what we've done in the past.
Okay, thank you. Okay, let's go back to audience. There, yep, right here. Can we get a microphone?
Hello, my name's Pat Moore. I'm with GAI Consultants. We're an engineering firm. I did have close to 15 years experience at Westinghouse, so you know, close to my heart. We talk a lot about the nuclear reactor designs and the nuclear island, but one thing I kind of want to get your perspective is looking at basically the BOP side, the outer limits, partnering with agencies for those. What about site locations, siting? I mean, we've seen the nuclear industry, any of the new nuclear industries are always at nuclear sites. And any insights on new locations and partnering with organizations?
So I think the question is about siting nuclear plants as opposed to not just the reactors, but where do you site them? Yeah, so I think, you know, obviously for nuclear, we have to go through that permitting process. We have to make sure the sites are appropriate for nuclear plants. So we go through that. Obviously, there's NIMBYism issues. We have to, you know, as the question came up earlier, we need to make sure that we pick the right sites and the best communities that are ideal for our customers. Customers today are going where the power is. You know, they are willing to locate their data centers or, you know, whatever where the power is. So as an industry, we are trying to identify the best locations. You know, best locations in terms of connectivity, you know, fiber connectivity, water availability, and workforce availability. So many aspects kind of come into that site selection. Not an easy task. And, you know, obviously we have to go through many steps, like I said, including permitting and, you know, community engagement, you know, efforts to make it happen.
Anything else? Okay. I have a question in the back.
Hello? Okay, as a former Westinghouse employee, I'm very excited about the opportunities to build AP1000s. At the same time, Pittsburgh's nuclear ecosystem extends far beyond a single vendor. How do we balance those demand signals, not only from Westinghouse, but also companies tied to the region like Forge Scott Forge, as you mentioned, Vistra, and developers like NewScale and TerraPower, who are also involved, I believe, with at least Scott Forge to some degree and Vistra. And then ensuring that those academic partners in Pittsburgh, such as Pitt and Penn State and Carnegie Mellon, which has a renewed interest in nuclear, are ensuring that we still maintain that brain trust in Pittsburgh. So how do we kind of balance all of that? Because you know, the focus today has been rightfully so on AP1000, but there's other companies out there.
Who wants to go first?
I'll start. I would say the first thing is the more we can all be engaged up front with the design, with how things are going to be manufacturing. So concurrent engineering goes a long ways because they have ideas, we have ideas. So if you can get everybody in the same room talking to each other, there may be things we can't do, but there may be things we can do that will help the design and smooth the flow into the supply chain. So big proponent of the upfront concurrent engineering.
And going back into the universities and stuff, like that, one thing for Westinghouse, you know, we're not looking for nuclear engineers. We're looking for mechanical engineers, electrical engineers, civil engineers. You know, getting nuclear engineers are great, but it's those ones that can get into the shops, get hands-on with the suppliers, understand if a problem arises, how they can solve it quickly with the supplier, and kind of looking for those resources. I mean, we have internships. We just finished up our summer internship here just a little bit ago, so we're reaching into the communities doing that. We're also, you know, bringing international interns over to teach them about nuclear and stuff. As far as, again, I'm Westinghouse, so, AP 1000 is what I'm pushing. But, any new nuclear is good for the industry, no matter who the customer is, whether they're a competitor or like EDF's a competitor and they're our best customer, right, over in France. But anytime there's new nuclear, it's good for the industry. It grows the supply chain. It keeps the doors open within our suppliers. And then to make sure things aren't getting, the shops aren't getting overloaded, that's where those capacity analysis come into play, where you go and you do this stuff now prior to placing purchase orders.
Fantastic. We have about 1 minute left. If there's any more quick questions. Okay. So I want to give a round of applause for our panelists here. Thank you all.